Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor from Aero Education Network, and today I'm going to solve some past paper questions from International A-Level Edexcel P1 Pure Mathematics 1. The topic is straight line graphs, chapter number 5, which is also known as coordinate geometry. So we have a topical past paper handout. So first of all, we have question number 3 over here, which is June 2006 C1 question number 11. So the question says that the line L1 passes through the points P and Q. P is -1, 2 and Q is 11, 8. The requirement of part A is to find an equation for the line L1 in the form y is equals to mx plus c, where m and c are constants. So first thing first, we are going to find the gradient of the line PQ. So in order to find the gradient of the line, the formula is y2 minus y1 divided by x2 minus x1, meaning change in y coordinates divided by change in x coordinates. So gradient of the line PQ is supposed to be 8 minus 2 divided by 11 minus minus 1. So 8 minus 2 is 6 and 11 plus 1 is 12. So gradient of the line PQ is half. Okay. And when we are finding the equation for the line PQ, so the gradient of the line is half and it passes through point P as well and Q as well. So I'm choosing point Q. Alternatively, you can choose point P as well. So I'm going to use the form of equation of a line like this: y minus y1 is equals to m multiplied by x minus x1. Alternatively, what you can do is you can use this form as well: y is equals to mx plus c, and use the gradient and the coordinate q 11, 8, and first find the value of c, and then you express the equation of the line in this particular form which is required in the question. But I'm using this approach over here, so both approaches are completely fine. So y minus 8 is equals to half multiplied by x minus 11. So this means y minus 8 is equals to half x minus 11 over 2. And then when we make y the subject, so y is equals to half x minus 11 over 2 plus 8. So minus 11 over 2 plus 8 is 5 over 2. So y is equals to half x plus 5 over 2. This is supposed to be your answer, equation of the line PQ. We have expressed the equation of the line PQ in the form y is equals to mx plus c. Okay. Alternatively, what you can do is you can use this particular method as well, where the equation of the line is in the form of y is equals to mx plus c, where m is the gradient and c is basically the y-intercept. So if you choose the coordinate q, which is 11, 8, and the gradient is half, so you can say that 8 is equals to half multiplied by 11 plus c. So c is 8 minus 11 over 2, which is supposed to be 5 over 2, and therefore the equation of the line is y is equals to half x plus 5 over 2. All right. So I have used point Q in both of these approaches. Alternatively, you can use point P as well. So this was basically an alternative explanation. All right. So the answer to part A is y is equals to half x plus 5 over 2. So now let's move on to part B. So we have some information that the line L2 passes through the point R, which is 10, 0, and is perpendicular to the line L1. All right. So the lines L1 and L2 intersect at point S. Calculate the coordinates of S. All right. So what we are going to do, we have the equation of the line L1 from part A. We are going to find the equation of the line L2 first. And what we know, the fact is that L2 is perpendicular to L1. So as we know that when the lines are perpendicular to each other, So the product of their gradients is equals to -1. So I'm going to solve part B over here. So I'm going to say that the gradient of the line L1 multiplied by the gradient of the line L2 is equals to -1. Since L1 and L2 are perpendicular to each other, so the gradient of the line L1 is half and the gradient of the line L2 is unknown. Okay, so I'm going to say that the gradient of the line L2 is -2. All right. So in order to find the equation of the line L2, the gradient is -2 and it passes through the point R, which is given to you in the question. Okay, so first I'm going to find the equation of the line L2. So I'm going to say that y minus y1 is equals to m multiplied by x minus x1, where the coordinate x1 comma y1 is the point which is given to you or you have found. Okay, so in this case, the coordinate is given in the form of x1 comma y1. The point is given to you in the question. So I'm going to say that y minus 0 is equals to -2 is completely multiplied by x minus 10. So y is equals to minus 2x plus 20. This is the equation of the line L2. Okay. And as we know the fact that from the information in the question that L1 and L2 intersect at the point S. So since we have obtained the equation of L2 over here as well, so I'm going to solve these two equations simultaneously in order to obtain the point of intersection S. Okay, so I'm going to equate both of the equations with each other. So half x plus 5 over 2 is equals to minus 2x plus 20. So half x plus 2x is equals to 20 minus 5 over 2. So half plus 2 is 2.5, meaning as a fraction, this is 5 over 2 into x, and 20 minus 5 over 2, this is supposed to be how much? This is 35 over. So I can say that 2 and 2 are cancelled out. 2 and 2 are cancelled out, and therefore x is equals to 35 divided by 5, meaning the x coordinate of s is 7. And then I'm going to find the corresponding value of y by substituting in any of these two equations. So I'm substituting this into line 2, equation of line L2. So y is equals to minus 2 times 7 plus 20, meaning y is equals to minus 14 plus 20, which is supposed to be 6. So therefore the coordinates of s are 7 comma 6. This is supposed to be your answer to part B. Okay, I hope everything is clear up till this point. So far we have attempted part A and part B. Then in part C, it is asked to show that the length of RS is 3 root 5. Okay, we need to give an exact form, 3 root 5 over here. So I'll do the working for part C on the next page. Okay. So as we know that the coordinates of S are found in part B, which is x coordinate is 7 and y coordinate is 6. Okay, and the coordinates of R, they are given to you in the question. So I'm going to say that we are going to find the distance between R and S, and for that purpose we have this formula under root of x2 minus x1 whole square plus y2 minus y1 whole square. This will give us the length of the line RS, which we can also say that this is the magnitude of the line RS. Okay, because the distance is always positive. So this is a usual practice to uh, express it like this. Otherwise, if you just write RS, so that is also perfectly fine. No worries with that. So under root of x2 minus x1 whole square, so 7 minus 10 whole square plus y2 minus y1 whole square, so 6 minus 0 whole square, meaning under root of minus 3 whole squared plus 6 squared, meaning under root of 9 plus 36, which is under root of 45, and under root of 45 can be expressed as under root of 9 multiplied by under root of 5, and under root of 9 is 3. So 3 root 5 units is supposed to be your answer. This is the exact length which is required in part C. All right. So now let's move on to part D. So the requirement of part D is hence or otherwise find the exact area of triangle PQR. So what we are going to do, we are going to use the information which is given to us. So what we know the fact is that P and Q both are on the line L1, and L2 is perpendicular to L1, and L2 passes through the point R. And what we know that the point of intersection of L1 and L2 is point S. Okay, so we are going to make a sketch over here. All right, so if I make a rough sketch, first of all we have the line L1, which is an upward sloping line which is having a gradient of half. Okay, point P and point Q are on this line. Okay, so point P is -1, 2. Let's say somewhere over here, and Q is um, 11, 8. So let's say somewhere over here. All right, and L2 is basically perpendicular to L1. This line is L1, and L2 is perpendicular to L1. So I'm going to make the line like this. All right, they both are perpendicular to each other, and what we know is that the point of intersection of L1 and L2 is S, which is 7, 6. And we know the fact is that uh, point R is on the x-axis and point R is on the line L2. All right. So, so one thing I need to make sure is that the x coordinate of R is less than the x coordinate of Q, because Q is basically 11, 8. So I'm going to move this point Q above. Okay, just to make sure of some accuracy. So let's say point Q is over here. Okay, this would make sense that Q is 11, 8 and R is 10, 0. P is -1, 2, and S is 7, 6. So we have a perfect sketch over here. So what we need to find the area of the triangle PQR. Okay, so PQR, I'm going to connect the points over here. All right, we need to find the area of triangle PQR. So what we know the fact is that the length of the line RS is 3 root 5 in an exact form which we have already found in part C. So the base of the triangle is basically PQ. The base of the triangle is PQ and the height of the triangle is 3 root 5. All right. So what I can say is that in order to find the area of triangle, half into base into height, area of triangle PQR, half into base into height. So the base of the triangle is PQ and the height of the triangle is RS. So the length of RS we have already obtained in part C. So I'm going to find the length of the line PQ. Okay, so in order to find the distance between P and Q, meaning the magnitude of the line PQ, under root of x2 minus x1 whole square plus y2 minus y1 whole square, meaning -1 minus 11 whole square plus 2 minus 8 whole squared. So the magnitude of the line PQ is under root of -12 whole squared plus -6 whole squared. So 144 plus 36 inside the under root. This is under root of 180, and under root of 180 in a simplified form is 6 root 5. Okay, so half into base into height. So area of triangle is half into the length of PQ is 6 root 5, and the length of RS is basically the height of the triangle, because this is the perpendicular distance from point S to point R. Okay, so this is the height of the triangle. So the length of RS is 3 root 5, which we found in part C. So 6 root 5 multiplied by 3 root 5. Okay, so and then multiply by half. So half multiplied by 90, meaning 45 units square is your answer. This is the exact area of the triangle PQR. This was the requirement of part D. So one way is to do it like this, okay, where you use all of the information which you have obtained in the earlier parts and the information which is given to you in the question, and you just make a sketch, okay, and just use the fact that the area of triangle is basically half into base into height, where height is basically the perpendicular distance which you obtained over here, meaning the length of the line RS. Okay, so this is how you attempt part D. This was basically the method number one. An alternative way, an alternative approach to do this part D is basically to use this concept area by shoelace shoestring method. Okay, and as per the language of the Edexcel marking scheme, this method is known as the determinant method. Determinant method. Okay, so I'm going to give some detailed explanation over here for this particular method. So area by shoelace shoestring method, you can use this particular method when you want to find the area of any shape when you have the coordinates given to you, or you have found the coordinates. This particular method would apply on all of the shapes excluding circle, all shapes except for circle. So I'm going to also explain that why this cannot apply on circle in the end. Okay, I'll explain this thing in the end. So the thing is that when you have, let's say you want to find the area of triangle ABC. Okay, so let's say A is in the form of x1 comma y1, B is in the form of x2 comma y2, and C is in the form of x3 comma y3. So let's say you have a triangle ABC over here. Okay, so first I'm giving just a brief explanation for this method, and then I'm going to apply this onto this question and bring the answer for you. All right, so you have these 3 points A, B, and C. So you are going to use the area by shoelace shoestring method. So the formula is area is equals to half multiplied by, first you will make an absolute value function, meaning the modulus function. Okay, and then you write the coordinates like this: x1, y1, x2, y2, x3, y3. Okay, and then the starting point again, which is x1, y1. And then you close this absolute value function sign, meaning you close this modulus sign over here. Okay, so you started from point A, so x1, y1. Then you moved on to point B, x2, y2. Then you moved on to point C, x3, y3. And now you want to move again onto point A in the same sequence. So starting point, I have mentioned this again. You have to mention, you have to write your complete formula in this way, and in the end the starting coordinate will be repeated. All right, in this case we are going to find the area of triangle. If you want to find the area of any four-sided figure, let's say trapezium, rectangle, kite, rhombus, parallelogram, okay, any four-sided figure. So in that case, you are going to write your formula like this, that x1, y1, x2, y2, x3, y3, then x4, y4, and then x1, y1 again. Okay. So the students which are studying from me in my online classes, they are already well aware of this method, and we have covered this particular method in detail along with examples. Okay, but just for the sake of giving some explanation for this video, because I'll be making this video public on my channel, so the new students can, I mean those students which are not studying from me at the moment, Okay, so they can also have a brief explanation over here for this particular method. It is very helpful. Sometimes it is very effective to use this method. All right. So you are going to write your formula in this way. And after that, what you are going to do, I'll just take a screenshot of this. Okay. And I'll enlarge the picture over here. And we will basically use a particular pattern. Okay. So in order to find the area, first of all, you write half multiplied by the modulus sign. And first of all, you follow this pattern, x1 multiplied by y2 plus x2 multiplied by y3 plus x3 multiplied by y1. Okay, x1 y2 plus x2 times y3 plus x3 times y1. Okay, you add all of these terms and then you follow the opposite zigzag pattern like this: x2 y1, x3 y2, x1 y3. Okay, but you write the subtraction sign over here. You will subtract the terms now. Okay, so after the subtraction, I'm going to make a bracket. So first of all, x2 y1 by following this opposite zigzag pattern. So x2 y1 plus x3 y2. Okay, and then x1 y3, x1 y3. Okay, and then you close the modulus sign over here. And then you are going to evaluate this complete thing in order to get the area. One thing which I like to mention over here, this sign we have used, which is a modulus sign. So P1 students are usually not aware of this thing. So I'll just give some explanation over here. What you know, the fact is that the magnitude of anything is positive. Let's say if I say that absolute value of 2, this is equals to 2. Let's say if I say modulus of minus 2, this is also equals to 2. So this is basically the modulus function over here. Okay, the students in P3 are basically they are aware of this particular concept. So I'm just going to give some detailed explanation. I mean some brief, very brief explanation over here. Okay, so when you write modulus of x, so this is basically like this, or you can say this absolute value of x. So basically what happens is that the input of this function can either be positive or negative, but output is always positive. Okay, what I'm trying to explain is that let's say you have something modulus of 2, this is equals to 2. Let's say you have modulus of minus 2, this is also equals to 2. So the modulus of a number is basically the magnitude of that number. Okay, this much explanation is more than enough over here. Okay, so what we are going to do, we are going to just use this formula. So I'm going to write the coordinates of p, q, and r. P was minus 1 comma 2, q was 11 comma 8, p was minus 1 comma 2, q was 11 comma 8, and r was 10 comma 0. Okay, so we are going to find the area of the triangle by shoelace shoestring method. Okay, one thing, that why is it known as shoelace shoestring method as well? Because if you see this sequence, this zigzag pattern and opposite zigzag pattern, so these two arrows, they give you something like a shoelace, in the way a shoelace or shoestring is tied up. Okay, that's why it is commonly known as shoelace shoestring method. All right, so what I'm going to say that area is equals to half multiplied by, first you make the modulus sign over here. So minus 1, 2, 11, 8, 10, 0, and then you mention the starting point again, minus 1, 2 again. All right. So from whichever point you are starting, you have to come back at that particular point. All right, what I'm trying to say is that in this case, I have started from P, then I wrote point Q, then R, and then P again, starting point again. Let's say if you start from Q and you decide to go up till P. Okay, so first you write Q, then you write P, then you write R, and then you will write Q again, meaning the starting point again. So it's totally up to you, whichever sequence you want to choose. All right, we'll just get the answer over here and then we will move on to the next question. Okay, so area is equals to half multiplied by the absolute value function sign, meaning the modulus sign. So first of all, we have minus 1 times 8 plus 11 times 0 plus 10 times 2. This zigzag pattern. Okay, so minus 8 plus 0 plus 20. Okay, I'll make the arrows over here. Okay, and then you use the subtraction sign and then you follow the opposite zigzag pattern. Look at these blue arrows now. So 11 times 2 is 22, 8 times 10 is 80, and minus 1 times 0 is 0. And then you close the modulus sign over here. All right. So area is supposed to be half multiplied by what? First you make the modulus sign, and 20 minus 8, this is 12. All right. And then subtract 22 plus 80 from this. So subtract 102. So this means that half multiplied by modulus of what? Modulus of minus 90. So what I'm trying to explain you, the significance of this modulus sign over here is that, as we saw that the modulus of any number is basically the magnitude of that number. Modulus of any number is the magnitude of that number. As we saw that in a basic example, the modulus of 2 is 2 and the modulus of minus 2 is also equals to 2. So therefore, I'm going to say that the modulus of minus 90 is also equals to 90. So half multiplied by 90 will be your answer, meaning 45 units square. All right. So in this way, you can find the area of this triangle. All right. It's not compulsory to use this, but this alternative method is usually mentioned in the Edexcel marking schemes as well. Okay. This is commonly known as area by shoelace shoestring method in O level and IGCSE additional mathematics. And as per the language of Edexcel marking schemes, this is known by this term, determinant method. Okay. So it's up to you which particular method you want to use. So I thought to just give some detailed explanation for this method. Otherwise, what I did earlier was this way, that whatever the information which was provided to you in the question and whatever the information which you have obtained in the earlier parts, you can use them and make a particular sketch, a very rough sketch. Okay, just make sure of these small things, that this coordinate, the x coordinate of point R was basically less than the x coordinate of Q. So accordingly, I made a sketch over here. All right. So this was basically the question number 3 of the handout, which is June 2006, question number 11 of C1. So now let's move on to the next questions. And one more thing before actually moving on to the next question, uh, I need to tell you this thing, that why this method, area by shoelace shoestring method, cannot be applied onto circle, meaning why it can be applied onto all shapes except for circle, meaning it would be only applied to the shapes which are edged, meaning quadrilateral, parallelogram, trapezium, four-sided figure, five-sided figure, pentagon, hexagon, octagon, these type of things. So this would only apply to this these particular shapes. So why this cannot be applied to the circle? Let's say you have a circle like this. So let's say if I have point A, B, C, D, E, Okay, I have these 5 points on the circle. So if I use this method, so I would get the area of this five-sided figure pentagon. Okay, I would not be getting the area of the circle by this method. Due to this reason, this cannot be applied to the curved shapes. You can say that this does not apply to the curved shapes. Okay, like circle, uh, oval, etc. This would be only applied to the edged shapes. All right, four-sided figure, five-sided figure, six-sided figure. As far as the coordinate geometry which is concerned in your A-level maths, okay, so these would be applied onto those particular shapes which are having the coordinates which are known to you or you have found. So this would not be applied to the curved shapes. So in particular, I've mentioned this shape circle. Okay, so this cannot be applied over here. So this method will give us the area of this pentagon. Otherwise, on the circle, you can make infinite number of points. Uh, as I've obtained a pentagon over here, you can obtain an octagon over here. You can obtain a 15-sided figure as well, 16-sided figure as well. So that is the thing. So this was just some brief explanation regarding this. Let's move on to the next question. This one is handout question number 6. Okay, so it says that, and this is basically June 2008, C1 question number 10. It says that we have a sketch over here. Points Q, R, they lie on the line L1. Okay, as you can see in the figure 2. And the length of QR is A root 5. You need to find the value of A. Okay, so first thing first, we are going to find the distance between Q and R, meaning the length of the line QR, or you can say the magnitude of the line QR. So under root of x2 minus x1 whole square plus y2 minus y1 whole squared. So point Q is 1 comma 3 and R is 7 comma 0. So under root of x2 minus x1 whole square, meaning 7 minus 1 whole square plus 0 minus 3 whole squared. So under root of 6 squared plus minus 3 whole squared. So 6 squared is 36 and minus 3 whole squared is 9. So under root of 45, meaning under root 9 multiplied by under root 5, which is supposed to be 3 root 5. So we need to just make a comparison with a root 5. Therefore, a is equals to 3. Find the value of a. So a is equals to 3 over here. This was part A. Then the information given to you is the line L2 is perpendicular to L1, all right, and passes through Q and crosses the y-axis at the point P as shown in figure 2. Find an equation for L2. Okay, so first of all, we are going to find the gradient of the line L1, which is the line QR. So in order to find the gradient of line L1, you can use the coordinates Q and R respectively. So y2 minus y1 divided by x2 minus x1. You don't need to mention the formula again and again. I'm just mentioning this just for the sake of formality. So the gradient of the line L1 is supposed to be the y coordinate of r is 0. So 0 minus 3 divided by 7 minus 1. So minus 3 over 6, meaning gradient of the line QR is minus half, meaning the gradient of the line L1 is minus half. So what we know the fact is that L1 and L2 are perpendicular. Okay, so I'm going to say that the product of their gradients is equals to minus 1. So gradient of the line L1 multiplied by the gradient of the line L2 is minus 1. So minus half multiplied by the gradient of the line L2 is minus 1. So therefore, the gradient of the line L2 is minus 2 divided by minus 1, which is supposed to be 2. Okay, and what we know that point Q is also on the line L2 and Q is 1 comma 3. So when you are going to find the equation of the line L2, you need to find the equation of the line which is having a gradient 2. 2 and it passes through the point Q which is given to you in the question, which is 1 comma 3. So we are going to use this form. Y minus y1 is equals to m multiplied by x minus x1, meaning y minus 3 is equals to 2 is multiplied by x minus 1. So y is equals to 2x minus 2 plus 3, meaning y is equals to 2x plus 1. Okay, not a specific form of the line is required. Otherwise sometimes uh, the requirement of the question is that give your equation of the line in the form ax plus by plus c is equal to 0, where a, b, and c are integers or where a, b, and c are rational numbers. So in this case, any specific form is not required. So y is equal to 2x plus 1 is completely fine. You will get full marks over here. Okay, so this was the requirement of part A and part B. Now let's move on to the next part, part C. You need to find the coordinates of P, and for that purpose, I'll bring the question on the next page. So far, what we know is that the value of A was 3, meaning the length of the line QR was 3 root 5, and the equation for the line L2 is y is equals to 2x plus 1, right? So we need to find the coordinates of P. So P is basically the y-intercept of the line L2. Okay, so since we can see that when x is 0, y is 1, meaning if we just make a comparison with the form of y is equals to mx plus c, so the y-intercept c is equals to 1. Therefore, the coordinates of P are when x is 0, y is 1. All right, this was just for 1 mark. What you can show is that as a working, because state was not mentioned, huh? Otherwise, usually in these type of questions, the keyword is mentioned is state. Here we have the keyword find. So it's better to just show a piece of working over here, which is you are substituting x is equal to 0 into the line L2. So y is equal to 2 times 0 plus 1. So y is equal to 1. Therefore, coordinates of P are 0, comma 1. This is the answer of part C. Okay, otherwise if the state was mentioned, if the keyword was a state, so if you just write your answer, state your answer, that would be also sufficient. All right. Then in part D, you need to find the area of triangle PQR. So it's totally up to you. Either you use shoelace, shoestring method, or you can just simply use this sketch. And what we know the fact is that L1 and L2 are perpendicular to each other. Therefore, this is the height of the triangle QR. QR is basically the height of the triangle. Okay, as simple as that. And we are just going to connect this point P and R over here. Let me just connect them. So the base of the triangle is PQ. PQ is basically the base of the triangle. So first of all, I'm going to find the base of the triangle. Okay, here's the working for part D. So the magnitude of the line PQ, or you can just simply say the length of the line PQ, under root of x2 minus x1 whole square plus y2 minus y1 whole square. The coordinates of Q were 1, comma 3, and the coordinates of P are 0, comma 1. Okay, so the length of the line PQ is under root of x2 minus x1 whole square, meaning 0 minus 1 whole squared, plus 1 minus 3 whole squared. So under root of minus 1 is squared plus minus 2 is squared, meaning under root of 1 plus 4, which is under root 5. The length of the line PQ is under root 5 units. So therefore, you can say that the area of triangle PQR is half into base into height, meaning half into PQ multiplied by QR. And the length of QR we have already obtained in part A, which is 3 root 5. So just simply use this method. So half multiplied by the length of the line PQ is root 5 and the length of the line QR is 3 root 5. Okay, so 3 upon 2 multiplied by root 5 times root 5 is 5. So 3 upon 2 multiplied by 5, meaning 15 upon 2 units square is your answer. Either you write your answer as 15 over 2 or just simply 7.5 units square. This is supposed to be your answer. All right. Alternatively, you can do by area by shoelace shoestring method as well. We need to find the area of triangle PQR. So I'm just going to simply do the working for shoelace shoestring method. The detailed explanation I've already mentioned above. So the coordinates of P are 0, comma 1. Okay, coordinates of P are 0, comma 1. Q is 1, comma 3, and R is what? R is 7, comma 0. All right. So area by shoelace shoestring method. So area is equals to half multiplied by what? X1 Y1 meaning 0 1, then X2 Y2 meaning 1 3, then X3 Y3 meaning 7 0, and then you come again at the starting point which was P over here, so 0 1 again. And then you close this modulus sign. Okay. So area is equals to what? Half multiplied by, first you follow the zigzag pattern. So first you follow this pattern. So first you have 0 and then 1 times 0. This is again 0 and 7 times 1 is 7 and then subtraction sign. And then the opposite zigzag pattern. 1 times 1 plus 7 times 3 plus 0 times 0. So 1 times 1, 7 times 3 and 0 times 0. And then you close the modulus sign over here. All right. So this is how you perform the steps. So area is equals to half multiplied by modulus of 7 minus 22. So 7 minus 22 is minus 15. So area is half multiplied by minus 15. So area is equals to half multiplied by 15, which is 7.5 units square. Okay. All right. In the marking scheme of this particular question, this alternative method, area by shoelace shoestring method, is also mentioned. I can show you the picture. Just give me a minute. I'll bring the screenshot of the marking scheme on the screen. So here is the marking scheme for this question. Okay, you can see that this method is clearly mentioned, and I've explained this method in significant detail for the purpose of this video. All right, our answer is 7.5, or you can write 15 over 2, same thing. Okay, 15 over 2 or 7.5, both are fine. Okay, so this was basically question number 10 of this paper, June 2008, C1. Okay, and here is the marking scheme and here is the proof of this particular method over here. All right, so now let's move on to the next question. So now let's move on to the next question, which is question number 10 of the handout, which is question number 8 of C1 paper, June 2010. So the question says that find an equation of the line joining point A and point B. Point A is 7, 4 and point B is 2, 0, giving our answer in the form ax plus by plus c is equal to 0, where a, b and c are integers. So first thing first, we are going to find the gradient of the line AB. So gradient of AB is supposed to be y2 minus y1 divided by x2 minus x1, meaning 0 minus 4 divided by 2 minus 7. So minus 4 divided by minus 5, which is supposed to be 4 over 5. Okay. And when I'm finding the equation of the line AB, so the gradient is 4 over 5 and it passes through the point B, which is 2, 0. I'm using this point B. You can use point A as well. Okay, so y minus y1 is equals to m multiplied by x minus x1. All right, so I can say that y minus 0 is equals to 4 over 5 multiplied by x minus 2. but we need our answer in a specific form, which is ax plus by plus c is equals to 0. So this means that 5y is equals to 4x minus 8. So 4x minus 5y minus 8 is equals to 0. This is supposed to be your answer. All right, we have expressed our answer in the form ax plus by plus c is equals to 0. So now let's move on to part B. In part B, it says that find the length of the line AB, leaving your answer in third form. Okay, so I'm going to do the working over here. So you need to find the magnitude of the line AB, meaning the length of the line AB. Okay, so under root of x2 minus x1 whole square plus y2 minus y1 whole square, meaning under root of 2 minus 7 whole squared plus 0 minus 4 whole squared. Okay, so under root of minus 5 whole squared plus minus 4 whole squared, meaning under root of 25 plus 16, which is under root 41 units. This is supposed to be your answer. We have to leave our answer in third form. Okay, so this was part B. Now before part C, we have some information that the point C has coordinates 2 comma t, where t is positive and the length of AC is exactly equal to the length of AB, meaning the distance between A and C is equal to the distance between A and B. So we need to find the value of t, and this is worth 1 mark. So what we can see is that the coordinates of A are 7 comma 4, B is 2 comma 0, and C is 2 comma t. And the magnitude of the line AB is under root 41. Okay, so A is basically 7 comma 4 and C is 2 comma t. Okay, so I can say that under root of 2 minus 7 whole squared plus t minus 4 whole squared, this is exactly equals to under root of 41. So I'm going to take whole square on both sides. So t minus 4 whole square is equals to 41 minus 2 minus 7 whole squared, meaning 41 minus 25. So t minus 4 whole square is equal to 16, meaning t minus 4 is equals to plus minus 4. But since, t is positive, t is strictly speaking greater than 0. So if you choose minus 4 over here after square root, so t will be equal to 0. So we don't need that thing. We need t minus 4 is equals to 4, meaning t is equals to 8. So the value of t is 8. All right. And since this this part is worth 1 mark, you can find your answer in least possible working as well. Okay, so I'll just explain an alternative approach for part C. What we can do is, so far, what we have the information, as much as information we have right now and we have obtained in earlier parts, we can make a sketch. And this sketch would also help us in part D as well. Okay, so I'll just make a sketch of all of the information which I have. The coordinates of A 7 comma 4. Okay, and B is basically 2 comma 0. Okay, so B is on the x-axis. B is basically 2 comma 0, and C is basically 2 comma t, and t is positive. And since AB and AC are equal, so this means that the magnitude of the line AB is equal to the magnitude of the line AC. We would have an isosceles triangle. So point C would be on the line x is equals to 2, because the x coordinate is also 2, but the y coordinate is positive. So now we can see that we have an isosceles triangle over here, in which we can say that the length of AB is under root 41 and the length of AC is also under root of 41. Okay, so here we have an isosceles triangle. So now the fact is that this triangle is an isosceles triangle. So if I make a horizontal broken line over here, this isosceles triangle will be broken into two halves. one half is above this horizontal broken line and one half is below this horizontal broken line. Okay, so what I'm trying to explain is that, you know, the half of the triangle which is below this horizontal broken line, so it would be exactly identical to the half of the triangle which is above this horizontal line. Okay, I mean to say is that this horizontal broken line would basically act as a line of symmetry in this triangle. Make sense or not? Okay, so the thing is that if we consider this point A, the y coordinate of A is 4, meaning this length is 4. When this length is basically 4, so this length is also supposed to be 4. So t can be obtained in this way, 4 plus 4. Okay, or you can simply say t is equals to 2 multiplied by 4, meaning 2 multiplied by the y coordinate of A. Okay, this is the thing. Otherwise, this won't be an isosceles triangle then. Okay, since we know the fact that AB is equal to AC, which is equals to under root of 41. So this is an isosceles triangle. Point C is having the x coordinate 2 and the y coordinate of C, which is t, is positive. It is above the x-axis, above the horizontal axis. Okay, so t will be equals to 2 multiplied by the y coordinate of point A, meaning t is equals to 8. All right, because the matter of fact is that this length is 4, so obviously this length is also 4. Okay, that is the thing. So t is equals to 8, you can obtain it in this way as well. This was an alternative approach for part C. And this sketch would be also helpful for us in attempting part D, in which we are going to find the area of the triangle ABC. Okay, so now the coordinates of C we have obtained, meaning the y coordinate of C is 8. We have obtained this thing. I'll just take the screenshot of this and bring it on the next page so I can find the answer for part D. We need to find the area of the triangle ABC. Okay, so T is basically 8. So C is now 2 comma 8. Okay, and the base of this triangle is BC, which is equals to 8. We have obtained this, and now we are concerned with finding this height of the triangle. Okay, which is basically the perpendicular distance from point A to the line BC. All right, so I can identify that, you know, this length is 4. Okay, let's say if this point is R over here. Okay, so the length of RC is basically 4. What I'm trying to do is I'm going to find the length of AR. So just consider this triangle. Just consider this triangle over here, which is ARC. Okay, and the length of RC is 4, which is basically the half of BC. And the length of AC is under root 41, which you already know. And under root 41 is basically the hypotenuse. Okay, so I can say that AR squared will be equals to hypotenuse squared minus this RC squared, meaning 4 squared. So 41 minus 16, which is supposed to be 25. So AR square is 25. So AR is under root of 25, which is supposed to be 5 units. The length of AR is 5 units, meaning the height is 5. And other thing is that, you know, uh, since this AR is a horizontal line, okay, and what we know the fact is that this coordinate of R would be 2 comma 4, right? Because R is on the same horizontal line as A, but R is also on the same vertical line as B. Okay, so basically this AR is change in X coordinates, which is 7 minus 2. Okay, so this piece of working is also some extra. Okay, What you can do is you can just simply find this length of AR by finding the change in x coordinates, which is 7 minus 2, which is 5 units. As simple as that. So this working would not be needed. Otherwise, if you do it, that's completely fine, no worries at all. But this much working would not be needed. You can simply find AR by this way. Okay, so whatever clicks your mind first, you can do it in that way instead of thinking much. I just realized the fact that this was a horizontal line. So after obtaining this AR is equal to 5 units, I saw that, okay, you can find the length of AR in this way as well because it is a horizontal line. All right. So the length of AR is 5 units. Okay, so we have obtained the height of the triangle. So therefore, the area of triangle ABC is supposed to be half into base into height. The base is the length of BC and height is basically, AR. So half multiplied by the length of BC is 8 units. So half multiplied by 8 multiplied by 5. So 8 times 5 is 40. 40 divided by 2, meaning 20 units square is your answer. 20 units square is your answer. All right. Alternatively, you can do the area by shoelace shoestring method as well. Okay. The coordinates of A are 7, 4. All right. Point B is 2, 0 and point C is 2, 8. So you can use area by shoelace shoestring method, which I have explained earlier. So half multiplied by the modulus sign. So first of all, you mention the modulus sign. And then first I'm mentioning point A, so 7, 4, then 2, 0, then 2, 8, and then point A again. All right, so half multiplied by what? First of all, you follow this zigzag pattern. So this thing will be 0 plus 2 times 8, which is 16, plus 2 times 4, which is 8, and then opposite zigzag pattern. So 4 times 2 is 8, plus 2 times 0 is 0, and 8 times 7 is 56. Okay, and then you close the modulus sign. So half multiplied by what? First you have 16 plus 8, this is 24, and minus what? 8 plus 56. 8 plus 56 is 64. So 24 minus 64, this is minus 40. So this means half multiplied by modulus of minus 40, which means half multiplied by 40. So this is supposed to be 20 units square. This is supposed to be 20 units square. So you can find your answer in any way. All right. So in this way, we have obtained the area of triangle ABC. All right. So this was basically handout question number 10, which is question number 8 of C1 June 2010. So in this video, I've discussed these 3 questions. So inshallah, I'll be uploading more videos. So stay tuned to my channel and thanks for watching. Assalamu alaikum.